All right, so we're moving on to 4.3, where we worked on multiplying and dividing rational expressions. This is where we really kicked it into gear with our factoring. We do a ton of factoring in this lesson. So multiplying and dividing rational expressions, I already said that, but what I meant to do is read this. Write an equivalent expression, specify the domain. So one thing we want to remember about the domain is the domain is from the original problem or original expression. Let's just call it that. So maybe I will just talk about the domain first, and then we can see how this expression would simplify. So the domain, the issue, and why we have to even talk about domain is rational expressions are fractions, and we now are introducing having a variable in the denominator. In math, we have to make sure that we never divide by zero. Things become undefined when we divide by zero. So that means that this x right here, it can't equal every single number out there. We have to make sure that we never let x be the value that would make your denominator equal to zero. So for a domain, it's a focus on the denominator. What we do is we say that our denominator, whatever it is, does not equal zero. And then we solve this equation. This is just a two-step equation. This is an x to the first power. So this will be easy to solve. Sometimes we have to factor before we do our solving, but I'm going to subtract 3 from both sides. I can see I'm going to be a little small on space, although maybe I can, oh, there we go. You guys might be a little more short on space. I apologize for that if you run out of room. All right, so 2x does not equal. Again, I'm subtracting 3 from both sides, so it's going to be a negative 3 over there. Divide by 2, so x cannot equal a negative 3 halves. That is going to be our domain. If we let x be a negative 3 halves, if we were to plug a negative 3 halves in right here, 2 times negative 3 halves plus 3 would equal 0, and then this whole thing is undefined. So that's the only restriction we have in our domain. Every other number would be fine. All right, now write an equivalent expression. What we're going to do is we're going to see if we can do any factoring and then reduce our factors. So now I'm going to go back to the problem. The 4x plus 6, we always look for a GCF first. I can see that I could factor. So now what I'm going to do is I'm going to say, let's just factor this. All right, we can factor a 2 out of the numerator. That leaves us with a 2x plus 3. Remember, when we factor out a GCF, we divide it out of each term. The denominator, 2x plus 3, has no GCF. That one cannot factor any further. And now what we have is a 2x plus 3 over 2x plus 3. So those are factors that we can reduce. This is a 2x plus 3 divided by itself. It equals 1, which technically is why we get to cross that off. But when we are reducing expressions, we only reduce the factors. Okay, so then we say, well, what do we have left? All we have left is that 2 in the numerator. So this whole expression simplifies down to a 2. All right, let's move on to number 2. Again, I will talk about the domain first. Let's see, we'll do this. There we go. All right, so our domain, we need to make sure that we never end up dividing by 0. So what I'm going to do, I'm going to put does not equal 0 up here. I want to solve this x squared minus x minus 6 does not equal 0. But because it's an x squared and there's an x there, we have to switch up the way that we solve this. So we're going to factor this. We're going to get it into factored form, and then we can solve for x. When you have just the x squared, where your a value is 1, then we can just say what are factors of negative 6 that add up to negative 1. And those factors are going to be a positive 3 and a negative 2. So, nope, that is wrong. It's going to be a negative 3 and a positive 2. Did you guys catch that before I did? Probably. You guys are good like that. Okay. So, negative 3 times 2 is negative 6. Negative 3 plus 2 is this negative 1. All right, once you get it factored, then you can set each factor not equal to 0. Normally we would say equals 0, but remember we're trying to find what x cannot equal. If we solve each of these, we're getting x does not equal a positive 3 and a negative 2. And now we have our domain. Those are the only two numbers you have to avoid. If you let x equal a 3 or a negative 2, this denominator equals 0, which we cannot divide by, so the entire thing is undefined. All right, so now let's simplify the expression. When we simplify, we factor everything. We look at it in factored form, and then we see if any of our factors will reduce. All right, so first I'm going to look for a GCF. I can see in the numerator there's a 3 that we can factor out of both terms. That leaves us with x squared minus 4. I'm going to come back to that x squared minus 4. The denominator, I want to factor this denominator, but we already did that work. So I'm just going to copy down. We already know it's an x minus 3 times x plus 2. So use work you've already done, any chance you get. All right, now this x squared minus 4. This is factorable. This is a factoring pattern we call a difference of squares. We are subtracting two perfect square terms. So how this is going to factor is into an x plus 2 and an x minus 2. If I think about the 2 and the negative 2, those multiply to negative 4, and 2 plus a negative 2 adds up to 0. And do you notice how we don't have that middle term? Like here we had that x in the middle. When you don't have that middle term, that's because your b value was 0. So there's a 0x that's not written in there for us. All right, I'm going to carry over this x minus 3 times x plus 2. And now we look to see, do we have any factors that we can reduce? This x plus 2 divided by x plus 2, and that looks like that's the only thing we can do. So our final answer, we have a 3 in the numerator and an x minus 2 over, we have an x minus 3 in the denominator, and this is our simplified answer. All right, we got another one. So focusing on the domain first, remember your domain is when your denominator does not equal 0. We got to solve for x, but it is an x squared trinomial, so we're going to factor this. We're looking for factors of negative 35 that add up to negative 2. Those factors are x minus 7 and x plus 5. When we get that factored, we set each factor not equal to 0, and then we solve. So we know that x cannot equal a positive 7 or a negative 5. If we did let x equal a 7 or a negative 5 and plug those in for these x's, this denominator would equal 0, and then the whole thing's undefined. All right, now let's go back to simplifying this expression. Very tempting to take an x squared and cancel it with an x squared. But remember, you can only do that with factors. I can only cancel or reduce factors. This x squared is attached to the 13x plus 40 with that addition. This x squared is attached to the rest of this with this subtraction. So we always have to factor everything and then see what factors we can reduce. All right, so this 40, do we have factors of 40 that add up to 13? We do, 8 and 5. So x plus 5 times x plus 8 over. Now this denominator we want to factor, but we already did right here. So I'm just going to carry that down. X minus 7 times x plus 5. And now that everything is factored, we're looking for any factors that will reduce, and we have an x plus 5 divided by an x plus 5. And that is the only thing we have. So our final answer will have an x plus 8 in the numerator and an x minus 7 in the denominator. Final answer. All right, so now we're moving into some multiplication problems. Find the product. So this is going to be pretty similar to what we were doing before. And maybe that's where these can get a little bit tricky, just keeping them straight, all the different things that we're doing. We're going to find the product and the domain. We are multiplying this fraction times this. This will be easiest if we treat this like a fraction also. All right, so the domain is going to come from our denominators not equal to 0. So let's start with that. From the original problem, we want to make sure that this 5a plus 5 does not equal 0. And then this denominator is a 1, so no issues there. That 5a plus 5 not equal to 0, I'm going to, I guess I'll rewrite it. 5a plus 5 does not equal 0, so I'm going to subtract 5 from both sides. Divide both sides by 5, so a cannot equal a negative 1. So there's our domain. All right, now to find the product, what we're going to do is rewrite this problem in factored form. We want everything factored so that we can see if any of our factors, well, we'll talk about that in a second. Let's just rewrite everything factored. So this first 5a over 5a plus 5. The 5a does not factor. In the denominator, though, we have a GCF of 5. So let's factor out of 5. It will leave us with a plus 1. All right, times, now this 10a plus 10 has a GCF of 10. We factor that out. It leaves us with a plus 1 all over 1. Now, when we multiply fractions, we would multiply straight across and then see if we could do any reducing with our fraction. So what I do is I just say, well, I know everything in the numerator will stay in the numerator, everything in the denominator stays in the denominator. So I just do my reducing from here. I just look at that as one really big fraction. I see that there's an a plus 1 in the numerator that will divide by an a plus 1 in the denominator. We've got a 5 divided by 5, and that leaves us with an a times a 10, or a 10a in the numerator over a 1 in the denominator. So our simplified final answer is 10a. All right, so number 8, again, starting with the domain, we'll work with the original problem for that. Domain is when we got to figure out how to make sure our denominators never equal 0. So x squared minus 3x cannot equal 0. That's from this denominator. This denominator also, x minus 5, we don't want to equal 0. Otherwise, the whole multiplication problem would be undefined. For the first one, I see that we have a GCF of x. Both of these terms have an x, so let's factor an x out. Leaves us with x minus 3 can't equal 0. And then each factor, so x does not equal 0 and x minus 3 does not equal 0. So in our domain so far, x can't equal a 0 from this one. Here we'll add 3, so x cannot be a 3. And up here we would add 5 to get the x alone, so x also cannot be a 5. So our domain, those are the 3 values that x cannot be. All right, so now the multiplication problem, what we want to do is rewrite the problem with everything factored, because then we can reduce our factors. So I'm going to go back to the original problem up here, starting with the numerator, x squared minus 5x. These two terms have a GCF of x, so we're going to factor an x out, leaves us with an x minus 5. The denominator, x squared minus 3x, we already factored that right here, so x times x minus 3. Times, now this fraction, x plus 3 over x minus 5, there's no factoring to do there, so I'm just going to carry it down. X plus 3 over x minus 5. And now that everything's factored, when we do this multiplication problem, anything in the numerator would stay in the numerator, anything in the denominator stays in the denominator, so I am looking for factors that we might be able to reduce. I see there's an x minus 5 over an x minus 5. We have an x over an x, and that's all that we are able to reduce there. So our final answer will have an x plus 3 in the numerator, and the denominator has an x minus 3. So that's what we would get after finding the product of those two rational functions. Okay, let's try one more of these. So first, domain. Domain is when our denominator does not equal 0. So 3y plus 15 does not equal 0. 10y plus 40 does not equal 0. And we're going to solve all of these. So I'm going to subtract 15. 3y does not equal a negative 15. I'm going to divide both sides by 3. So y does not equal a negative 5. Over here, I'm going to subtract 40 from both sides. So negative 40. Divide both sides by 10. So y would not equal a negative 4. So those are the two values in our domain that we would have to avoid, a negative 5 and a negative 4. If we let our variable equal either of those, then our function or our multiplication problem would be undefined. All right, now let's go back to the problem. This multiplication, we're going to factor every single part of this that we can. That's going to help us see which factors will reduce to get us to our final answer. So first, the 5y minus 20, we've got a GCF of 5. We factor a 5 out, leaves us with y minus 4 over, now this 3y plus 15. There's a GCF of 3. We can factor that out, leaves us with y plus 5 times, now we'll factor this. Oh, we can factor a 7 out of those terms, leaves us with y plus 5. And then here we have a 10y plus 40. We can factor a 10 out, and that leaves us with y plus 4. Okay, because it's a multiplication problem, anything in the numerator stays in the numerator, anything in the denominator stays in the denominator, and I know that I can do any reducing. So I see a, what do we have? Well, y plus 5 divided by y plus 5. There's a y minus 4 and a y plus 4. Those would not reduce. Well, one thing I do notice is we have a 5 over a 10. If I had a 5 over a 10, that would reduce to a 1 over a 2. So it's like 5 over 10 reducing to 1 half. So our final answer, in the numerator we have left a 1, a y minus 4 times a 7. So I'm going to write the 7 first, 7 times y minus 4, and that 1 just wouldn't change it. Multiplying by 1 doesn't change what you're multiplying, what it's multiplying with. All right, in the denominator we have a 3 times a 2 times a y plus 4. So we can go ahead and multiply the 3 times 2 and get 6, and then times the y plus 4, and then this is our simplified answer. All right, so that was multiplication. Now we're going to look at division. Find the quotient and the domain. Where this is going to head, anytime that we have division, we change the division to multiplication and we flip this fraction. It's called multiplying by the reciprocal. But first we are going to find our domain. Domain, let's start with the original problem. We want to make sure that our denominator does not equal 0. So 24y to the 5th does not equal 0. Also, this 12y to the 4th can't equal 0. Now, we would solve for y here. It is a y to the 5th power. That's an idea we'll be getting to later in Algebra 2. But if we think about what value of y would make this equal to 0, and basically it's going to be a 0. 0 to the 5th power is 0 times 24 is 0, and that can't happen. So y cannot equal a 0. Over here, same idea. 0 to the 4th power is 0. 0 times 12 is 0, and that can't happen. So y cannot be a 0 from this one also. So I'm going to go ahead and say that y can't be a 0. I'm going to write domain. Y cannot be a 0. All right, now let's look at our problem. We're going to rewrite the problem, do any factoring if necessary. Do you guys see how these are single terms, monomials? There's no adding or subtracting to give us more than one term, like up here. That plus separates these two terms. So these are two terms, a binomial. These are all monomials. We can't factor a monomial. You have to have at least a binomial to do any factoring. So when we rewrite this, there's really no factoring to do, but we want to take care of that multiplying by the reciprocal. So we have 7x to the 4th over 24y to the 5th. The first fraction never changes. Now we're going to take our division and change it into multiplication. And now the reciprocal, we're going to flip this next one, 12y to the 4th over 21x. Now what that does by multiplying by the reciprocal is it introduces a new variable in our denominator. So we have to look at, and I'm going back to our domain. We have to look at the original problem with domain. We talked about how these denominators cannot equal a 0, but now that we have a new denominator, 21x, 21x also cannot equal a 0. And what value for x times 21 would equal a 0? That's going to be a 0. So x, or our domain with the second variable, we've got to add on to it. X also cannot be a 0. Because of that multiplying by the reciprocal, we introduced a denominator right here that had an x. So we have to talk about an x in our domain as well. All right. So when we simplify, well, again, so it's a let me having 10 thoughts in my head at once right now. So we're multiplying two fractions together. We can do the same thing where we consider it one big fraction and see if we can do any reducing between the numerator and denominator. I'm going to take care of the coefficients. I see we have a 7 and a 21. So if you have a 7 over a 21, you can divide those both by 7. 7 divided by 7 is 1. 21 divided by 7 is 3. We also notice we have a coefficient of 12 and a coefficient of 24. So 12 over 24, we can reduce both of those by 12. 12 divided by 12 is 1. 24 divided by 12 is 2. All right, so now I'm going to, just to simplify this a little bit, let's see where we're at. We have an x to the fourth times a y to the fourth over, we have a 2 times a 3, so we have a 6, y to the fifth times x, but we're going to alphabetize the variables, so we have a 6 x y to the fifth. All right, we can't keep simplifying because of the x's and the y's, so this 6 is going to remain in our denominator. It has nothing to reduce with. But here we have an x to the fourth divided by an x. Now, I am going to reduce the x's and the y's. We talked in a previous problem about, like up here, I can't cancel this 5a with this 5a because this 5a is attached to this 5 with the addition or subtraction. When you don't have any addition or subtraction, keeping terms together, then you can reduce them in parts. So if I have an x to the fourth divided by an x, that's going to leave me with an x to the third power. And if you think about, the numerator has x times x times x times x, so those x's, 4 of them are all up here. The denominator has an x down here, so this 1x is going to simplify away with one of these x's, leaving us with 3 x's left in the numerator. All right, the y's, we have a y to the fourth over a y to the fifth. So these y to the fourths will reduce with 4 of the y's down here, leaving us with a single y in the denominator. So there is our final answer. X to the third over 6y. All right, well, we have a lot to talk about on this page, don't we? 2 more problems to go. All right, so division problem, we want to notice that it is division, which means we're going to multiply by the reciprocal. But before we do any of that, let's talk about the domain, because we had to state the domain for all of these. Domain is when our denominators do not equal 0. So this denominator, y minus 7 squared, I'm going to go ahead and write it as y minus 7 times y minus 7. It cannot equal 0. Also, our other denominator, this y squared minus 7y, cannot equal 0. I see that there is a GCF of y, so I'm going to factor this before I find what value y cannot be. All right, so up here, first one, when we have y minus 7 times y minus 7, it cannot equal 0. We set each factor not equal to 0. But in this case, they're the same factor, so we only have to write it once. So y minus 7 can't equal 0, which means y cannot equal a positive 7. Over here, we have two factors. This y cannot equal 0, and this y minus 7 cannot equal 0. So here's my domain. I'm going to go ahead and include this 0. And then if I added 7 to both sides, that would be a positive 7, which we already have accounted for. So here's our domain. All right, and by the way, we might be adding on to our domain because I know that we're going to multiply by the reciprocal of this. And once I have that set up, I'll talk about it, but we're going to be introducing a new denominator into the problem, which means we have to think about the domain again. But why don't we go ahead and rewrite this problem in factored form. So this whole thing, I'm just going to talk about down here. So we're going to factor everything as we rewrite it. So y squared minus 49, that's that difference of squares. We saw that, I think, on the first page or the second page. I don't know, we saw it somewhere. Y squared minus 49, if you are subtracting two perfect square terms, this one's going to factor into a y plus 7 times a y minus 7 over, now this y minus 7 squared, we can just separate out those two factors, y minus 7 times y minus 7. All right, now our division, we change into multiplication, and then we're going to flip or write the reciprocal of this fraction. So that y squared minus 7y, let's factor it as we rewrite it, but we actually already did factor it. It's right there. So that's a y times a y minus 7 over, now 5y plus 35, we might as well factor that as we rewrite it. There's a GCF of 5. It leaves us with y plus 7. All right, so I mentioned a second ago that this denominator, 5 times y plus 7, we've just introduced a new denominator into our problem. So we have to make sure that this new denominator also never equals 0. If I solve for y, I could divide both sides by 5. So y plus 7 cannot equal 0. And then if I subtract 7, y cannot equal a negative 7. So we are going to add into our domain that negative 7. All right, now that we have everything factored, back to the problem, and we are multiplying these two fractions together, we can go ahead and treat it like one big fraction where anything in the numerator will reduce with anything in the denominator. So I see a y plus 7 with a y plus 7. Here's a y minus 7 divided by y minus 7. Oh, we have another y minus 7 divided by y minus 7. And we are left with a y over a 5. So our final simplified answer will be y over 5. Isn't it kind of cool how simplified these get when they start out so complicated looking? I'm sure that's exactly what you were thinking. Isn't this so cool? Maybe just me. All right, last problem for this page. So number 12, let's talk about the domain first. Domain is when your denominators cannot equal 0. So I'm going to say y squared minus 1 cannot equal 0, and y squared plus 5y plus 4 cannot equal 0. Y squared minus 1, we could add 1 to both sides and square root both sides, but this is another difference of squares. We are subtracting two perfect square terms, so we also could solve for y by factoring. Y plus 1 times y minus 1 does not equal 0. I just wanted to talk about factoring this one so we keep seeing that difference of squares factoring pattern. The more we see it, then we'll recognize it when we have to use it. All right, so once it's factored, each factor cannot equal 0. And then we solve. We would subtract 1 from both sides, add 1 to both sides, so y cannot equal a negative 1 and a positive 1. We have another denominator, y squared plus 5y plus 4. Let's factor this. Factors of 4 that add up to 5. That's going to be a 1 and a 4. Then we say set our factors not equal to 0. And we're getting y cannot equal a -1 and -4. Well, -1 is already here, but this -4 we're going to go ahead and add into our list over here. So here's our domain. Again, I'm thinking ahead that this is a division problem. So once we multiply by the reciprocal and we introduce a new denominator, we'll talk about the domain again. But let's go ahead and work on rewriting this problem where everything is factored. So that first numerator, y squared minus 5y plus 4, do we have factors of a positive 4 that add up to a -5? So factors of a positive 4, you can have two positive factors or two negative factors. Because they need to add up to a -5, we're going to want the negative factors. So these factors are going to be a y minus 4, y minus 1. So -4 and -1 multiply to positive 4, but they add up to a -5. All right, over, then we want to factor this denominator y squared minus 1, which we did right here when we were finding the domain. So I'm just going to carry that down, y plus 1 times y minus 1. Then our division in our problem changes to multiplication, and we're going to multiply by the reciprocal. So this y squared plus 5y plus 4 is going to the numerator, and we already factored it right here. So I'm just going to rewrite those factors. Y plus 1 times y plus 4 over y squared minus 9 goes in our denominator, but that is, again, that difference of squares. We're subtracting perfect squares. That's going to factor into y plus 3 times y minus 3. All right, now when we just did that, this is a new denominator, which means we need to make sure that this denominator never equals 0. So y plus 3 times y minus 3 can't equal 0. So each of those factors cannot equal a 0, which means we're going to add on to our domain. We have more things that we can't have. Let's see, from y plus 3 can't equal 0. I would subtract 3 from both sides. So y cannot be a -3. And then y minus 3 can't equal 0. I would add 3 to both sides. So y also cannot be a +3. So wow, we have a lot of numbers, 5 of them, that our variable cannot be. All the other numbers though, and there's an infinite number of other numbers that your y can be. So there's just 5 it can be. Maybe that's not so much in the grand scheme of things. All right, so it is a multiplication problem now. I'm going to go ahead and treat it as one big fraction, anything in the numerator that we can reduce with anything in the denominator. And really, this is the fun part, right? I see a y minus 1 divided by a y minus 1. Oh, here's a y plus 1 divided by y plus 1. And I think that's it. All right, so our final simplified answer, what we have left in our numerator is y minus 4 times y plus 4 all over y plus 3 times y minus 3. Oh, and page 2 is done. It only took me 40 minutes to talk about this. Not that big of a deal.